Hello, it is June 11th, and Paul, everything in our prep doc is about Microsoft. And so I think this is just going to be the Microsoft episode, right?
Well, I mean, a lot of them are. We talk about NPM and GitHub a lot, so it's I don't know if it's necessarily going to be any different. But and VS Code. Speaking of which, I'm not going to tease it. Well, I am going to tease it here, but I won't give it away. I'm working on a great image about this, and you'll love it. So,
I do love your AI images. I can't wait.
Stand by. Stoked.
I'm delighted. Okay, let's give a high level, because unlike most episodes where we jump around topic-wise a lot, these are all like kind of interconnected. So broadly, we're going to talk about three things, and then we may, ramble off into somewhere else. But we're going to talk about what appears to have been an attack on Microsoft that happened last week. We're going to talk about the new VS Code cooldown feature, and we're going to talk about NPM install scripts. Does that about sum it up?
Yeah, it does.
Okay, so I'm going to caveat all this with, I live in the Seattle area, and Microsoft is both, part of my everyday on the computer and also part of the community that I live in. And we're going to say some good things about Microsoft today. We're probably going to say some things that are not as complimentary. And I mean, that's just kind of the relationship I think a lot of people locally have, is there's pros and cons, and it's not the only mega tech company in the region. There's another one that perhaps is hated more. I'm sure, Paul, you know which one that is, but it's Amazon. Yeah, what do you want to start out with?
I don't know if I hate Amazon more than I hate Microsoft. I mean, my Microsoft hate goes all the way back to the 90s. So
it's deeply entrenched. Yeah, you don't live here, so you haven't lived with the blowback of living in the Amazon community.
Well, as I've mentioned to you before, I used to work for a company that had a headquarters there, and I have actually spent a lot of time. I've actually done training and done all kinds of stuff on the Microsoft and IBM campuses, and I might have even done something at Sun there years and years and years ago. So I have spent a lot of time in your area. But anyhow, that's beside the point. What order do we want to tackle these in? Well, we might as well do the repos thing first.
Yeah. So what? June 1st for me, June 2nd for you. I was starting to wrap up my day. It was your Saturday. And all of a sudden, you figured out that Microsoft had en masse disabled 73 repositories within 105 seconds. And in looking at the behavior, it was very evident that something had tripped GitHub safety settings and had, I think it was a TOS violation is what all the repos said. And so because of a TOS violation, they all got shut down. Where we first saw this was actually people who realized that their stuff broke, because these were some pretty high impact repositories. So Paul, you lived in it. Talk about what happened last week.
Yeah, so one correction. Sorry, it happened on June 5th.
June 5th. Sorry, time is weird.
It's okay. No, this has been, you said this last episode too, and it's true. Like, it all blurs together now, for God's sakes. Yeah, so basically what happened is a total of 73 repositories just went dark on GitHub. And as Jen said, the message that came up was saying, hey, we've disabled these repos for TOS, terms of service violations. Now, I was asleep when it actually happened, but I got up soon thereafter, and a couple of people I know actually grabbed snapshots of one of those repos before it got disabled. And it was pretty clear from the get-go that this was a Miasma Worm attack. But there was a lot of people pushing, like, I got some flack from people about, my blog post intimating that it was, the Miasma Worm. In hindsight, it was, and I probably shouldn't have softened my blog post, but anyhow, I did, to make people happy. which is never something I do normally. But the point is that what happened is that the durable task repo had been affected in May. I think it was May 18th.
I looked it up earlier today. It was like mid-May. I'll drop the threat report while you're chatting.
If I were to pull a number out, I think it was May 19 got done. And basically the assumption is that, in fact, Step Security goes so far as to say it happened, that persistent, that the threat actors maintain persistence via credentials I yanked in the first May 19 event, which then allowed them to come back on June 5th and do this. Now, basically, this is Miasma Worm, which is like a, similar or based on Team PCP's open source worm, and now there's a new version of it, and yada yada yada. So that's all craziness in and of itself. But I think the thing that's more important here, because this is the Microsoft show today, right, is that Microsoft still, I checked this morning right before this, still has not come out and officially said what happened. Or even
it's very like gives GitHub vibes from when GitHub got done a couple weeks ago, right? Like very quiet.
Listen, Microsoft, if anybody from Microsoft is listening, you probably aren't, because you probably know that I'm here, but you continue to just shovel. I'm trying not to say any naughty words. You're doing the bad thing, and you're making it worse and worse and worse. And I don't know. I'm leaving GitHub straight up. Like, I've already made the decision. We're leaving GitHub. I wasn't using any Microsoft products to begin with, but this is just a crap show, and I'm really disappointed, with the behavior from the organization. Not that I should be surprised, but yeah, they still haven't come out with any official word about it at all.
No, I saw a couple of quotes in, I think it was either TechCrunch or the Hacker News that allegedly came from somebody from Microsoft, where they said that they, looked through the repos, that most of them were unaffected. They say that they reached out to people who were affected, which I'm a little skeptical about, just given the way that these things work. I don't know that they necessarily know everyone who might have consumed this stuff, but maybe they do. Maybe they have a secret way.
I think you said something earlier on that I need to come back and touch on, which is that this had significant impact. This had real impact, because basically what happened is so basically 4 GitHub organizations were affected. And one of those GitHub organizations was the Azure Functions GitHub repo. And there's specifically GitHub Actions that run for Azure Functions that are housed there, and those were taken down. Those were disabled. And so what that meant is, if somebody was running a job that called the official Azure Functions, and there was like several of them, GitHub action, it failed immediately. And so I started, because I was the first person to mention this publicly, and I started getting people immediately pinging me on all my comms channels saying, hey, what's going on? And I've mentioned this to some people I know, and they're like, yeah, welcome to tech support. Yeah, and that's really what it felt like. It felt like I was tech support for Azure Functions GitHub action, and I didn't have any data to share. Sorry, I have nothing to do with it. But yeah, it had real impact. And the fact that Microsoft hasn't said anything about that very real impact to actual CI jobs around the world, that is bad. Super bad.
Yeah, it's not great. Maybe we'll come back to that. I want to talk about Miasma, but maybe that'll be a thing we tag on later. So the next thing, we saw an announcement about VS Code adding a 2-hour cooldown for third-party extensions. So something that's of note here is third-party. So that means it's stuff that's not owned by Microsoft. So little area of concern there for me, at least. If they get compromised, which we have seen them get compromised multiple times recently. So I think that there's a bit of a insinuation that first party is safe and you can consume it immediately, but third party will give you a 2-hour auto update cooldown period. Don't get me wrong. I think that this is a good step to have this as an option for people. I'll share the issue shortly, but it was requested in VS Code issue by the community. A lot of people wanted it. They cited a lot of the attacks that have happened recently and said, hey, we really need this. And like, if we diagnose why it's really needed, that's what also I think causes concern for us. Is the reason it's really needed is because there's no real screening for these extensions before they get released into the ecosystem. It is very much buyer beware.
100%.
Yeah, so it's good that there's a cooldown period. It's weird that it's 2 hours. That's definitely the shortest cooldown period I've seen. When I talk to people in the community, anywhere from 3 to 7 days is pretty average for what they want to be seeing for their own internal practices. So this like artificial, choice for 2 hours is weird. It's not what the community asked for. They didn't specify a time. So questions there.
So many questions. Taken as a whole, this is just kind of an odd thing. And when we talk about the next part of this, which is NPM, it's the difference between the two and the discrepancy is very unusual, because so a VS Code extension is really just a JavaScript package, right? It looks and feels exactly like an NPM package. It has all the same kit. It also has, in addition to having the dependencies that you typically have for an NPM package, it also has these extension packs, which is a way to call another extension as a dependency inside it. So it's got two planes of dependencies that you can call on. But it is strange that it's 2 hours. That feels like, Jen, I'm gonna use another one of my military analogies here, but it feels like you put a helmet on and then you run into a minefield. Like, I guess in theory it protects you to some degree, but it doesn't give you much protection. It seems like an odd number. I also think that they chose that number because they're doubling down on this idea, this primitive that, velocity is everything for developers. And let's be clear, velocity for developers is the number one reason that we have this problem, right? This is why we're looking at cooldowns and all kinds of other stuff across the board. It's because we have over incentivized velocity above everything else when it, developing software. So it seems like a weird number. I will say this though, the VS Code Marketplace is the one place where Microsoft seems to be fairly proactive around scanning extensions. It's because they remove things weekly from the VS Code Marketplace. I know because I track it. And it seems strange to me too, because like, are they using the same technology that they use for NPM? Because they sure aren't pulling anywhere near the same number of things. And it just seems weird.
And the timing is interesting. So I spent some time, I guess it must have been earlier this week, rereading the retrospective by NX on the NX console VS Code extension compromise. And I had misunderstood, and I think I misspoke on a previous version of this podcast, that Microsoft had caught the malicious extension. That is not correct. NX caught it. The reason they caught it is they had notification emails set up through VS Code Marketplace to notify them anytime a new version was public. And so one of the maintainers got an email and said, whoa, I didn't do this. Very quickly realized it was malicious, and it took them about 11 minutes to get it pulled down. Interesting, because I wanted to understand the difference between that and OpenVSX. What they say about OpenVSX is that does not have an email notification system. They did not know that it also pushed there. And what they said in their retrospective was, and I'm sure we've all been there, the developer had maybe I should check OpenVSX moment after they dealt with the VS Code Marketplace one, saw that it was there, and then manually pulled it down from that one also. And so that's why you have the time difference. So first off, knowing that this particular scenario happened because the vendor was proactive, not because of any inherent scanning in the platform, but also the dichotomy between VS Code Marketplace and OpenVSX. I did a little bit of poking around this morning because I thought, okay, if this was a problem with that particular situation, are these cooldowns going to be applied to OpenVSX also? No indication that that will be the case. And so, we find edges with these things. I mean, is it surprising? No. But I wrote a post earlier today that was kind of talking about how all these ecosystems that are sort of under the same umbrella are getting security measures added to them, like in silos. Like you can almost see the org chart that's working on these things rather than it being a cross organization initiative.
Yeah, I mean, just from like the artifact that you install perspective, as you say, we have two different, not competing, but two different big VS Code marketplaces. We've got the Microsoft official one, and they're pretty, proactive about pulling stuff down. And then you've got OpenVSX, which is run by the Eclipse Foundation, and they're not very proactive about pulling things down. In fact, they're not proactive at all. They do take things down pretty quickly, I think. I've actually never disclosed to them, which is, it's like,
well, it sounds like from the NX situation that they did act quickly once they got a hold of these people,
and that's good. But there's a number of small differences between the way that you publish things in OpenVSX and you do in Microsoft, which actually makes OpenVSX an even sexier target for bad guys. Now, what I was getting at here is you can also just host these VSXi files yourself and let people install them, right? So it has a lot of the kind of same distribution problems that you have with AI skills, which is anybody can write an AI skill.md, put it out on GitHub. People are going to index looking for those. They're going to suck it into all these different skills registries, and so suddenly now, just by putting on GitHub, you suddenly get this distribution channel, and you don't have to do anything. It's like a zero input distribution channel. It's perfect.
That's interesting. You and I haven't talked about that similarity before. That's a lot to think about.
Yeah, well, and the Go ecosystems like that too as well. Like every Go package is actually just a GitHub repo, and so and this is true in other ecosystems too as well. And I think this is the feeling. I feel like this is where more things are moving towards, which means that bad guys have this kind of automatic distribution mechanism whenever they publish stuff there. It's crazy.
Yeah. Okay. Third area on our list is the NPM version 12 breaking changes notice that they put out. Was it yesterday? I think it was yesterday afternoon. This is a good thing. Let's not dance around it. But again, like everything that we've been talking about, there's like teeth, thorns, whatever metaphor you want. There's something pokey in it also. So, we've seen a huge amount of them. Open source malware leverages these install scripts in NPM. It's effectively an automatic installation method. That is why
RCE by design, right?
RCE by design. A lot of AppSec teams think about scanning for malware later in the lifecycle, when it hits CI. But these lifecycle scripts and install scripts specifically are what makes the malware fire before it's gotten anywhere near your pipeline or production. And so what they've done is they have disabled these by default. So they are now opt-in, or they will rather. They say that this is going to be coming in July, that it'll be a major breaking change. They're not kidding. A lot of stuff is going to break if you upgrade to this new one. But I want to talk about a concept that I think is really important in security, and it's certainly not limited to security. I learned about it long before I entered this field, and it is the concept of make the right thing easy, make the wrong thing hard. And they sort of did and didn't do that with this. They made the right thing easy by making it opt-in, which is something you and I have talked about a lot, is if you want people to adopt a security feature, don't make it a choice. Just have it turned on from the beginning. This is why we haven't seen a lot of adoption of capabilities like trusted publishing, because you have to do work to get it to work. Yep. But on the same token, developers are going to need to opt in to these install scripts, because a lot of the packages that they use simply won't function without them. And they're going to develop the bad habit of just opt in, opt in, opt in, opt in. So you've written a whole blog about this. I really like what your thought process is here. So what do you want to add in?
Yeah, I mean, I think that first, like you said, I'm just going to say it again because people see me as a hater, and I'm not a hater. These are all good changes. I love the fact that they've tripled they've tripled down here in the sense that not only are they disabling the install lifecycle scripts, so post, pre, and install scripts, they're also disabling the direct Git, the ability to pull dependencies via Git, and also the remote tarball method. Because when I first heard people talking about this, I was like, well, the first thing the bad guys are going to do is just pull, dynamically from a URL or from a Git repo, and they're addressing all three together, which is great. That's a very that's something to be commended. I mean, it's coming years and years and years and years too late, but the damage has already been done, I guess. But it is a good thing. So I think there's
at least it's not a partial fix. That's a good thing.
Agreed. Yeah, and I was really surprised to see them tackle all three of those in one change. I thought that was great. To be commended. So I think, and I say this in my blog post, I think there's this, especially in the InfoSec community, which frankly doesn't understand how the software sausage is made, right? They think that lifecycle scripts are only used by bad guys, and that's not true. And I point out like 8 or 10, popular packages that use install scripts. And then there's also the native kind of JIP, build that has become very popular as well that requires that as well. So the reality is this will absolutely break production all around the world. But here's the other thing: is this isn't a registry change. This is a package manager change, right? So that means you have to update to version 12.x on your local machine, whether that's your developer workstation or whether that's in your CI, to be able to get this built-in security. And as we all know, just don't take my word for it. Go and look on GitHub and find find the versions of NPM that people are using in their GitHub Actions, right, all around the world, and see what versions they're using. They're not typically using the most up-to-date versions. So this is going to take months or years to actually kind of, dribble out. So there's just, this is not going to be this one-time kind of security existential change that I think people are calling it. It's not going to be.
That's a great point. This will be a years-long slog. I mean, we see this all over the software ecosystem. Kubernetes made some major breaking changes a couple years ago. They recently discontinued Ingress Nginx. There's a whole bunch of problems around that. We know that people choose not to upgrade or miss the message about why they need to upgrade for whatever reason. The human just likes, human brains like status quo. Like opting into a change is always a barrier to adopting the change.
Yep. I mean, all we have to do, and I point this out in my blog post, is all we have to do is we just look at another ecosystem, which we've already talked about today, which is also owned by Microsoft, the VS Code ecosystem. And you look at what they did in VS Code 1.109, I think, came out in January of this year.
Oh, you're talking about the task.json stuff?
Yeah, where they disabled by default task.json running, the task files running automatically. Like heaps of people still aren't running that version of the IDE. Like, so it's like, I talked to somebody, it would have been a few months ago, would have been out in March maybe, but I talked to somebody, I was like, I'm like, what version of VS Code are you running? He's like, some ridiculously old version. I'm like, why? And he's, I just, I got all this stuff built in and I don't want to upgrade. And I'm like, okay, well, there's still that kind of person too as well. Yeah. So these are good changes. We want to keep saying this. We want to keep qualifying what we're saying as saying these are good changes. All things together, defense and depth and, multiple controls. These are all good things. Yeah. But I do not think this is going to be this like existential change, like no more malware and NPM. I made the name of my blog post that, right? There's still going to be heaps of malware and NPM for years, even after this change rolls out.
Yes, very true. Okay, we glossed over something that happened in the last week, and that was the threat actor behind Miasma, or Miasma, however you pronounce it, open sourced it.
They did.
Right.
Well, and the person that open sourced it too as well does not appear to be a compromised user, and that's odd too as well. So with the Team PCP open source, the assumption, or well, no, it's not the assumption. Basically, if you tie this back, and if I get this wrong, Francois or somebody else will correct me, and I'll come on the next one and say this, but I'm pretty sure the first event in the GitHub API for the Team PCP open source repo was actually on a compromised user's account.
Oh, so meaning that the threat actor used a compromised user's account to publish it. Yeah.
Correct. And that was that's their model. And then, and North Korea is doing that with Pollen Rider and Glass.
Yeah, it's just easier to, obfuscate who actually did the thing.
Right. Because there's a lot of data in the GitHub API. I mean, they're about to make it harder to get at, but there's a lot of data in the GitHub API that me and, a lot of my friends, use. So anyhow, fast forward to Miasma. It appears that the person that open sourced the source code is not a compromised user. It appears that they're like a quasi security researcher. And so that's got me thinking like, okay, what's going on there? So inquiring minds want to know, and my Git forensics is all over it. So it was an odd thing.
I'm looking forward to seeing how that resolves for sure. Okay. I think we have a couple more miscellaneous topics. We've got a couple minutes to talk about them. I think this might be a good time to talk about package firewalls. We're hearing about it a lot from vendors right now. It seems like every other week, an AppSec or some kind of registry related vendor launches some kind of package firewall offering. And I thought it would be helpful to people listening to kind of talk about what these are, how they work, how can you decide if you need one, how it's different from EDR. I don't think we're going to make a judgment here on whether they're good or not. That's up to individuals to decide on. But essentially what it does is it enables you to block consumption from the developer machine of specific packages. And where this is, I guess, the problem that it's seeking to close is, all right, you don't have an internal registry as your sole way of consuming open source. You've got some other way, people can get around them even if you do have an internal registry, but you are looking to add a layer to make sure that people don't consume known or potential malware. So let's start from there. Paul, what do you want to talk about with these?
Well, I think it's hilarious because I was pitching this idea of like EDR for the developer back in 2023 and 2024, and nobody gave a doo back then, right? And now suddenly they're all very popular. Listen, I think to your point about us making a judgment, I think that package firewalls are part of a quiver of tools that you would use to protect yourself, right? And so I think that having the ability on an endpoint to not install and have visibility around what is malicious and what's not is an important control.
And to be clear, a proactive control, not a, oh shoot, it's there, like EDR.
Yeah, correct.
Would be the difference with EDR. EDR finds it after you've
right.
ingested.
Yeah, EDR ain't helping you here. Like standard EDR ain't helping you here. I think there's a lot of issues with these package firewalls because we lump them all in together. And like, listen, Liren Tal wrote one of these things back in 2017, right? NPQ. It's pretty simplistic, but there's lots of examples of these. And Patrick Dwyer recently wrote something called Package Ward, which I think is cool. But basically these fall into two kind of camps. The first is the more simplistic camp, which all it does is create an alias on your machine that says, if I call pip, if I call npm, instead call this other tool, and that tool will then make a call out via API or however it works. Some of them actually cache locally on the machine, which I think is a terrible idea. The problem with an API is that it adds latency, and if you got a big package manifest, that adds a latency. But caching for malicious packages today, like I just think is
not
a
a
bad
good
idea.
idea. Don't do that
across the board, right? The problem with having that first example is that you don't have a process running like in user space saying, just kind of running all the time looking at these things. Instead, what you're doing is you're calling just at a point in time this other app that says, hey, can I do this thing? So you don't have this kind of daemon that's sitting out there checking to see, hey, what's calling pip? What's calling npm? And that's where the second category comes in. The second category comes in. Some of the more advanced tools in this space actually run effectively a daemon that look at all calls out, right? And so this is where you start to, blend over into this proxy that you've got running, because many of these tools also run a proxy. They look for calls out to, pod hosted or npm.js registry, and get in the stream, right? So there's two kind of categories, and these two different kind of categories have different outcomes. A lot of these tools actually just use OSV and GHSA for their malicious package feed, which is not enough. I mean, that's the reason that, we built OSM. We do have open source maintainers that are running some of these now, incorporating into OSM's feeds, which is great. But yeah, I mean, it's an important tool to use.
Yeah, and I think there's a couple things to think about before you pick one. Paul, you've surfaced a couple of those. One is, what's the data source? If you're going to be paying a vendor to, license one of these things, then you want to understand, where are they getting their malware data? How fresh is it? What happens if it's a package that they haven't seen yet? Is there some kind of process to investigate that package before approving it? So understand that part of it. The other one that you mentioned was the local caching, which kind of goes back to that freshness part. If you're caching an older list of, malware, then you're missing the most, I guess, threatening possibility that it's an account takeover that's brand new and you don't know about it yet, and you're in that short time window.
Yep.
The third thing, and this maybe, I don't know, you and I think have slightly different opinions about this, but this is an individual's ability to get around it. These are not, I don't know what the right silly security metaphor is. This is a wall you can walk around if you want to walk around the wall.
Well, yeah, it's super,
And that's
especially
just to
that
understand that.
The first version, where it's just basically what you're doing when you call pip or npm, you're just calling an alias. Literally all you have to do to bypass that is just to call the absolute path on your machine where pip or npm actually lives, and you immediately bypass that control. It's that simple, which I think is, too simple, because here's what's going to happen is your developer is going to be, I want to install this package, and your firewall comes up and says, hey, that's a bad package.
Or
that
it's
person
slow.
goes out or it's slow. Yeah, exactly. Good point. It's slow. This thing's slow. I just want to install my thing. I'm trying to run build. I'm in the process. And so maybe some n percentage of the time that person gives a crap enough to go out and look up whether that package is malicious or not. And maybe they don't find anything. They see it's wrong. And so they just bypass the process and they just install it, right? It's a very simplistic, and someone explained to me why they were putting so much energy into it, saying, well, this is a trust mechanism with developers. Developers are incentivized to build and deploy as quickly as possible. So if something gets in their way, they're going to buy, especially if it's as easy as just calling an absolute path to bypass something, they're going to do that, right? Some n percentage of the time, they're going to do that.
Yeah. So going back to, if you decide you need one of these, look at how easy it is to bypass. It comes back to, you can have a policy that says if you bypass it, there are job related ramifications. You can have the stick instead of the carrot approach, but really just sort of understand it, because I think these do get treated a little bit simplistically. And with all that said, I do think it's going to be still not the majority of organizations choosing to implement these,
I
and the
agree.
reason I say that is because internal registries still are not a standard in the industry. And if we haven't gotten to the point where an internal registry is not the standard, then I think about the um, stakeholder engagement that is needed to get something like a package firewall rolled out in your system. If you're having trouble getting a registry done, the firewall might be tricky also. All of that said, now's the time to ask because, like Paul said, he had this idea years ago. When I first started working in the space years ago, nobody cared. Nobody turned on the features that looked for malware. It's not 2023. Good news. It's 2026. Yes, it is. And so most people understand at least why you want to be looking for these. So like if this has been on your wish list, like, yeah, now's the time to do it. You don't have to buy one. I know people who are building them. So you could look into building it yourself. It doesn't have to be go buy it off the shelf. But yeah, go check it out. Go talk to people.
Agreed.
See what's possible.
Agreed. Yeah,
And
one
actually,
of those companies.
I'm talking about this, there's a similar one. Our friends over at GitGuardian developed an endpoint solution that lets you see what secrets are deployed on your developer machines. Whether you use something from GitGuardian or some other solution, that is the other side of the puzzle or whatever solution here.
Yep.
You do need to know what's on those developer machines, both from a package perspective and a credential perspective. If you don't have those two things, then you're going to be really behind when it comes to dealing with malware.
Agreed. It's really interesting because 99.9% of NPM or PyPy based malware are info stealers, right? And I don't know if that number is actually true or not, but it's it's in the zone. But because of that, understanding what credentials are on your developer machine is super important. And I'm trying to think who it was. Somebody built a tool recently, and I'm it's going on my head. But basically, the whole intent of the tool. Oh, I know what it was. It's Francois and Boost security with Bagel. Bagel basically actually runs on a developer's machine and says, "Hey, these are the credentials. And this is the stuff that's stealable here." And I was listening to Francois on the open source security pocket for Josh's Bresser's podcast.
Oh, I missed that episode. I'll have to check it out.
Yeah, it's really good. Just came out. And on that podcast, they were talking about the fact that the org that Francois was working for got popped. And first, just mad respect to him for talking about that, because it happens to all kinds of organizations and nobody talks about it. They actually, not only did they talk about it, but they went and built tools to like address it. And I think that's dope. So yeah, Bagel is the whole idea there is to like expose what's on the developer's machine. So now from an incident response perspective, I almost did it. Shizzle, there's some bad stuff. The production AWS keys were on this machine, and they ran this this NPM info stealer. Oh boy, we need to spend some time dealing with this.
Okay, I found the podcast. I just dropped it into the comments. This is a great point for us to wrap up. We went a tiny bit long, but I think this was a good topic for us to dive into. So
I agree.
Hope it was useful. Let us know if there's other like technologies that you want us to talk about. Again, we're not going to necessarily make total judgments on, well, I don't know. We might if we think like it really is snake oil, but I don't know that there are any that are necessarily that right now.
Yeah, I don't know how much snake oil there is, but there's a lot of things that people are describing overly simplistically, and I won't call out any of those vendors, but like they talk about things like being silver bullets, and they're not. So
yeah, well, we are a skeptical industry. I think people do tend to see through that. But anyway, this has been a good one. Tune in next week and have a good one.
Number 8 in the books. See y'all. Thanks for listening, people. Appreciate it.